Hello, my lovely students. So here's the last question from section 3.2. We are going to have to be speeding up more for the rest of this week, though, because I realize we're a day behind. All right, now let's just see if my pen will work. There we go. So determine the values of a and b that will make the function given below both continuous and differentiable at -6. Okay. So what we're going to see in section 3.3 is we'll get the start of the shortcut rules. So to make this graph continuous, the limit from the left has to equal the limit from the right. And the only place where we're unsure of the continuity is at -6. So we're going to do limit as x goes to -6 of ax plus b, and we want this to equal the limit as x approaches -6 of x squared. So if we plug in the -6 for x now, this will be a times -6 plus b equals -6 squared. So the -6 in parentheses means the negative also gets squared. So this is equal to +36. So it is -6a plus b equals 36. Now we could solve this for one of the two variables and then substitute that back into the equation. Then it would all be in terms of one variable, but we need a completely separate second equation in order to solve for both values. Solving for b in this equation is just going to give us an expression, not the value. So our other piece is that they are differentiable. So we want to calculate the derivative. Now the good news is for the top one, ax plus b, the derivative of that is the slope because it's a line. All right, so like here, so the derivative on that part is just a. So we just need to figure out the derivative on the other part. So f of x plus h will be x plus h squared minus f of x is x squared all over h. So we get x squared plus 2xh plus h squared minus x squared, still all over h. The minus x squared cancels out the x squared. We do have at least one h in the other terms. So this is now the limit as h goes to 0 of h times 2x plus h over h. The h's cancel, and now we can put 0 in place of h, and our derivative on the other side is just equal to 2x. So we want the derivative at -6 to match. So I have f prime at -6. On one side, this equals a. On the other side, it will equal 2 times -6, which is -12. Now, to be differentiable, these have to be equal. So we have that a is negative 12. And now that I know a is negative 12, I can substitute it in here. So negative 6 times negative 12 is a positive 72. And then we minus the 72. And that should be a negative 36. So in order for this function to be both continuous and differentiable, I need to make a negative 12 and b negative 36. So like just to write it all up, it would be negative 12x ends up being minus 36 for x less than negative 6. And then x squared when x is greater than or equal to negative 6. All right. So if we plug in negative 6, negative 12 times negative 6 is a positive 72. Minus 36 is 36. Negative 6 squared is 36. So the continuity matches up. F prime of x squared is 2x. And then if we plug in negative 6 for the x, we get negative 12. Slope of part A, the first part, is negative 12. So we have done it. We have found the a and the b values that make this function both continuous and differentiable. Now, if you're doing this homework after we did 3.3, feel free to use the power rule shortcuts. Just remember what you're taking the derivative with respect to.